Another thing that can occur in ions is something called a polyatomic ion. So we know ion is a charged particle. The word poly means many. So polyatomic, this means a many atom ion. And so these elements have bonded together to form a group, but they have a charge. That's what makes them an ion. But they still act together as a group. So you can see the definition: a cation, which would be a positive ion, or an anion, which would be a negative ion that contains more than one atom. I will tell you there's really only two common cations that are polyatomic ions. Two common, I'll say polyatomic cation. Oh, sorry. I gotta write it down here. I'm too close to the button. And the two common ones are the hydronium ion and the ammonium ion. Now this brings up the difficulty with polyatomic ions. They've got formulas that we have a harder time predicting. And then they have charges that don't necessarily follow a pattern. And what it ends up is that there's a lot that you have to memorize. And the more you work on memorizing things, the easier these polyatomic ions are. Now for this class, in the study guide, I have a list of the ones I want you to memorize. So you don't have to memorize all of them. It's a list either between around 8 or 9 polyatomic ions that you memorize. But what I recommend at first is you just open your book to the table that has the names of the common polyatomic ions while you work on it. Here's a couple examples. These are all anions or negative ions. So we have the sulfate ion, which you see is SO4, 2 negative, phosphate, and the nitrate. So that's the hard part, memorizing the name that goes with a particular formula. The easy part is how we name them when they get in the formula and how we write the formulas, because it's really not different than what we were doing before. So for example, if I'm looking at this one, I can still use the crossover. Now in my mind, I don't worry about that, okay? That is sulfate. It's going to stay as a group. I just have to look at the charges to help me know how to put it together. So potassium, because sulfate has a 2, oops, sorry. Do you see down here I have K2, and then sulfate, the whole group, since potassium has a 1, I just have 1 sulfate. So it's SO4. And how I name it is like before, I just named the two things. So I have the metal potassium and then sulfate. So it's called potassium sulfate. I'll erase this so if you can see my writing on my notes a little better. Let's try the next one. Now, I'm not going to even look at this when I'm writing the formula. So I think my calcium, I look up here, that's a 3. So it takes calcium with a 3. Now the phosphate, the PO4, I look back here and it takes 2. Because it's a group, I use parentheses and I say that group, PO4, I need 2 of them. So I use parentheses if I have to use more than one polyatomic ion to get it to balance. And then I name it, it's calcium, followed by the name of the polyatomic ion, phosphate. So on the next couple pages, I have some examples that we can try. Okay, so if you're given the names, you would have to, at this point, probably look up on a table, but some of them as you memorize. So if they wanted to write the formula, sodium, I could figure out the formula of sodium on the periodic table. It's group 1A, the alkali metals, and it's a +1. Bicarbonate, again, at this point, you might have to look on your in your book, but it's HCO3. Okay, so remember, don't pay so much attention to what's there at first. So just look at the charge. I have a 1 and a 1. So when the charges are the same, you take one of each. So I need an Na, and I just write the whole thing, HCO3. Now, because I only need one of them, I don't use a parentheses. Okay, so potassium, that's in the same group as sodium. That's a group 1A, it's a +1. And nitrate is NO3 negative. Okay, so again, kind of in your mind, shade that out. I just look at the charges, a plus and a -1. They're the same. So one of each. So I just have K and then 1 NO3. Now magnesium is group 2A, so it's a 2+. Phosphate is PO4 with a 3 negative. And I'm going to kind of not think about the PO4. So the magnesium, I look up there, and I'm going to need 3 of them because phosphate has a 3. The phosphates, I look there, there's a 2, so I put a parenthesis and I put PO4 with a 2. So if I have to use more than one polyatomic ion to get the charges to cancel, then you use parentheses. If you use a parentheses, for example, on this one, if you went K parentheses NO3, that is incorrect. Your homework won't accept it because it's not the right convention. So if you only use one, don't use parentheses. Now this last one, barium is in group 2A, so that's a 2+. Hydroxide is OH with a negative. Now remember, when I'm putting it together, I don't have to focus on the OH. But barium, I would see there's a 1 there, so it's just would take 1 barium. And then OH, I see there's a 2 there. So if I need more than 1 OH, I'm going to put a parentheses and write 2. Now again, the hard part of this, I think, is getting familiar with the polyatomic ions because they look a little overwhelming. But remember, once you kind of learn those, to put the formulas together, we're really looking at the charges, not the polyatomic ions. Now here I wanted to do some naming, so I gave you some formulas, and we named them. Again, at this point, I don't know how much you've studied, you may have to have the chart that gives you the names. But if you don't, you could try. So you could pause it and see what you can get. So we named these the same. This is a metal, so that's sodium. And then this is a polyatomic ion. If you look in your book, it's called carbonate. So I just say sodium carbonate. This is the metal, it's calcium. This right there is hydroxide. And again, I don't have to worry that there's 2 of them. In ionic compounds, you just name the 2 things that are there. Okay, this is magnesium. That is nitrate. And then this, I also have magnesium. And that is phosphate. So you see, naming them, once you're familiar with the polyatomic ion formulas, naming them, you just use the name of the polyatomic ion, along with, in this case, the metal. I want to write one more I should have written. Let's see. Okay, so this one right here, remember there's 2 polyatomic ions I mentioned on the first page, ammonium and hydronium, that are cations. And so this right here is the cation ammonium. So we would say ammonium. And then if the second one, if it's the anion you're naming, remember you have to change that to IDE. So that would be ammonium sulfide. Now the last thing that is on this video that doesn't have to do with the polyatomic ions, but it's just the properties of ionic compounds for you to review. So things about ionic compounds, because they have the crystal lattice structure, you can see that they have very high melting points and boiling points. The ions are very attracted to each other, so they make very strong bonds, and so it's hard to get them to melt and boil. Now, a lot of them are soluble in water, and it's what's really, really cool is when they're soluble in water, they will dissociate, and dissociate is a word that means like they fall apart. So it falls apart into ions, and those ions, remember, are plus and negative charge, and the ions will conduct electricity. So if you have salt water, for example, if I had water and I put in sodium chloride, what actually happens is the sodium ions and the chloride ions dissociate, and so those free ions can conduct electricity. We call those electrolytes. And we know, just if you might think of Gatorade, electrolytes are used in our bodies as part of our electrical current system. So just taking a look, the physical properties of ionic compounds really do have in large part to do with the structure of how ions get together in the crystal lattices and arrays.